Hello, today we are going to learn chapter 2 transfer function on rotational mechanical system with gear. So today the new topic is gear. So in a gear what we have is two parts of the gear. We are all more or less familiar with gear. We know there are the small one and another one is bigger one. When this gear works just like a lever, I hope you more or less can remember how the lever works. So basically what the gear do is, if you see here, the number of teeth on the smaller gear are much smaller than the number of teeth on the large gear. So this, when you can see, when this gear rotate 360 degree, this gear does not. This gear, for example, if this gear rotate 5 times, only then the larger gear rotate only once. So what is the benefit of such arrangement? We need to understand that. So we are talking that the theta 1 is always much greater than the theta 2, because we have a 5 rotation here. For example, number of teeth is 5 times higher than the smaller one. Number of teeth on the large gear is 5 times higher than the smaller one. So what will happen, if the smaller gear rotate 5 times, the larger one will rotate only once. It means that the displacement theta 1 is 5 times higher than the displacement of theta 2. So what happened to the T1, we will talk about in our next slide. So using the gear, we can do lot of things much easier. For example, we know that when a car or truck start from lowest gear, right? And then when it is speed up, then gradually we switch the gear to higher level, right? So let's talk about it in more details, and using this gear we will see this type of system, how to solve the transfer function. So in a gear, let's specify some parameters. For example, one parameter is the number of teeth. For example, in this case the smaller gear has n1 number of teeth, and this gear has n2 number of teeth, and the radius is r1 here, radius is r2 here. The displacement, the angular displacement is theta 1, and here it is theta 2. The torque on the left side is T1 and the right side is T2. Okay, so the relation from geometry, we can find this relation, theta 2 by theta 1 is equal to r1 by r2. We can find it from the geometry, and because the number of teeth is proportional to the perimeter and the perimeter is proportional to the radius, so we can rewrite this expression, theta 2 by theta 1 is equal to n1 by n2. So this is the first thing we have to remember. You can see this is inversely proportional. Theta is inversely proportional to number of teeth. That means if number of teeth reduces, the theta 1 will increases, and so on. And then we have to understand another relation between two torque, T1 and T2. We know from the principle of energy conservation is the energy supplied in this part will, if it is lossless gear, the same energy will be transmitted on the right side, to the right side. So the total energy on the left side is T1 theta 1, which should be equal to total energy delivered on the right side, which is equal to T2 theta 2. So what happened? So we can rewrite this two expression like this, that is T2 by T1 is equal to N2 by N1, or we can say T2 by T1 is equal to theta 1 by theta 2, which is equal to N2 by N1. We can see that the torque is proportional to the teeth, but displacement is inversely proportional to the teeth, inversely proportional. So we have to memorize this in order to solve our transfer function. So in another view, we can imagine like this, that we are giving a theta 1 input in the gear, but we are getting another output theta 2. Okay, so what is changing this displacement is the ratio N1 by N2. Okay, so we just written down from here theta 2 by theta 1, N1 by N2. You can see here. So this theta 1 is being changed to theta 2 by this ratio. Okay, so if you multiply N1 by N2 with theta 1, we can get theta 2. Similarly, if we multiply T1 with N2 by N1, we will get T2. So its system input is torque T1 and system output is torque 2. Now, this relation is important to understand the practical system. For example, if we have a heavy truck, like 5-ton truck or 10-ton truck, right? So initially, to move the truck, we need a lot of torque, and this increase in torque from T1 to T2 is only possible using a low gear, which will come from N2 by N1 ratio. So this is what we call low gear. For example, gear number 1. Then when the truck is speed up, we move to gear number 2, etc. So initially, this ratio is very high when we set the gear of a truck to number 1. So in that case, the ratio is higher, so the torque is higher initially and the truck start to move. Without using this gear, we cannot possibly move the truck using the same engine or motor. Okay, so this is the power of gear. So initially, if N2 by N1 is much higher or much large in number, the torque will increase, but on the other hand, the theta 2 will decrease. If N2 by N1 is much higher, then N1 by N2 will be much lower than 1. That means the speed will be very low, but torque will be very high, so the truck will start to move. This is how gear work. Now let's try to write an equation with gear. Let's solve this system. Here we can see a gear N1 by N2. This is the general symbol to express the gear, and we are applying a torque here T1, and we are having a displacement theta 1, and similarly we will develop a torque here T2, and we will develop a displacement theta 2 here, and which is attached to a mass or inertia, and which is also connected to a viscous damper and an spring. Okay, so this is the system. We have only two displacement here, theta 1, theta 2, and then and the other are actually theta 2 is active from here to here. We have theta 2 is also active here, and we can see that this damper and spring is also attached to theta 2, and there is no displacement here because this is a fixed wall. So now we need to write the equation for this system. We know to write the equation, what we do is we multiply the theta 1 with some impedance to get, and we set equal to T2, right? Theta 1 into something equal to T1. So this is the equation for torque, but there is a problem here. And what is it? The problem is that there is no impedance, inertia or viscous damper or spring on the left side of the gear. There is no impedance connected to theta 1. So how can we write the equation using theta 1? Can we? Actually we can, but right now you cannot. Using your present knowledge you cannot. So let's write the equation on the right side of the gear. This is the right side. So let's write the equation using theta 2. So we are trying to forget the left side of the gear, and we are trying to write the equation on the right side of the gear. So on the right side we have a T2, and T2 is equal to T1 into N2 by N1. We know it from the previous slide, right? So just have a look here. We could write T2 here, or we could write directly T1 into N2 by N1. So this is the right side of the gear. Now we are going to write the equation for this. Here just like our previous lecture, we are writing the equation theta 2 into all the impedance, that is j s square d into s plus k. So we have included all the impedance multiplied with the theta 2 is equal to T2, and T2 is equal to nothing but T1 into N2 by N1. So this is the equation. Now you know the rest, that if we want to convert this theta 2 to theta 1, we can write like this, that is N1 by N2 into theta 1 in place of theta 2. Okay, so now we get another equation where only theta 1 and T1 exist, not theta 2 or T2. So we can now rewrite these equations in this format. We can transfer this N2 by N1 to the left side, and we get N1 by N2 whole square, and we also distribute this N1 by N2 whole square into each of these part, that is j into this fraction, d into this fraction, k into this fraction. So we rewrite the whole expression here. So why did we rewrite this? Because we want to see what the general form of the equation using theta 1 and T1 look like. So we rewrite the equation like theta 1 into something is equal to T1. So that means all these impedance are connected with theta 1. Do you remember a little while ago we asked, can we write the equation theta 1 using theta 1 and T1? We said we cannot, because there is no mass or inertia, no viscous damper, no spring here. How can we write? Now we get the exactly same thing here. You can see this theta 1 is arriving in this equation, this T1 is arriving here, and all the impedance connected to theta 1 are appearing in the square bracket. Now let us see what are the impedance. So we can see that in the impedance there is something associated with s square, something associated with s, and some part is constant, right? So this is my inertia which is connected to theta 1, this is my inertia which is connected to theta 1, sorry, this is the viscous damper, and this is the equivalent spring. So we can express all this impedance in a picture. So now previously we have draw this diagram based on theta 2. Now we are drawing the same diagram based on theta 1. Okay, so based on theta 1 we can see that even though there is nothing here, but our equation is saying that there is a inertia which is equal to j into n1 by n2 whole square. There is a viscous damper with theta 1 which is d into n1 by n2 whole square, and there is a spring here, equivalent spring here. Okay, so now let's summarize it. To summarize it, we will say that we can write the equation based on either theta 2 or we can write the equation based on theta 1. If we write the equation theta 2, we just write all this according to our previous lecture. But if we have to write the equation based on theta 1, we have to transfer this j from the right side to the left side by multiplying a constant which is n1 by n2 whole square. So we have to, whatever impedance are on the right side, we have to transfer them to the left side in order to write the equation on the left side. Is it clear? It means that all of these impedance are connected to the left side as well, but their values are different. On the right side the value is j, on the left side the value is n1 by n2 whole square. So this is the difference. Similarly, when we are writing the equation on the left side, the viscous damper will change from d to this figure, and the spring k will change from k to this figure, which is multiplying by n12 and n1 by n2 whole square. So how do you remember this n1 by n2? It is very simple. We are going from n2 to n1. We are going from right side to left side. That means n2 by n1. So we are going to n1, and n1 will appear on the top. And we are going from n2, and n2 will appear in the denominator. So this is how we will remember this constant n1 by n2 whole square. I hope it is clear now. Now you can explain the phenomena. What is the advantage of the using gear in a truck? In a truck or in any other vehicle, when we start from the low gear, what happened that we reduce this n1 by n2 very low value. That means we keep the n2 much higher than n1, so that this ratio is much less than 1, and the overall mass or inertia become very low for the truck. So even though the truck is 5 ton, we can reduce it to 1 ton or even much less. Do you understand? So this gear is changing the weight of the truck or friction of the initial friction of the truck, etc. So this is how the gear work. I hope you remember these two figures in order to write the equation. And there is one more thing to include here, that is you do not have to write equations for both theta 2 and theta 1, just one. Okay, so you either write the equation for theta 2 or you write the equation for theta 1, but not both of them, because if you write theta 2, you can transfer this equation into the equation of theta 1 and vice versa. Okay, so basically both equations are same. You either write equation here based on theta 2 or based on theta 1, and then you can convert theta 1 into theta 2 or theta 2 into theta 1 as you like. Okay, so in this system actually the number of independent variable is only 1. Why? Because we can see theta 1 by theta 2 is equal to n2 by n1. Theta 1 and theta 2 are not independent, but they are dependent through a ratio n1 by n2 or n2 by n1. So they are dependent. They depend each other. When you know the theta 1, you can immediately know the value of theta 2 by using this ratio n2 by n1. Okay, so these two variables are not independent. Keep it in mind. We will use this concept later on. Okay, so we are not going to write two equations. We will rather write only one equation, either on the left side or on the right side. Okay, keep that in mind. Now next, practice one more example. Okay, so in this example we have included one more inertia on the left side, one more frictional constant here. So now we will try to write the equation either on the right side or on the left side. The same principle also applies here, that is theta 1 on the left side of the gear is dependent on the theta 2 on the right side, and these two displacement theta 1 and theta 2 are dependent variables. That means in this system, because this theta 2 is also applicable for d2 and k2, and there is no displacement here because it is fixed, and so there are no other variables in this system except theta 1 and theta 2, and these two are dependent, right? So how many variables, independent variables, are in this system? Only one. Only one independent variable, because theta 2 and theta 2 are dependent by the factor n2 by n1. So we will try to write down only one equation, either on the right side or on the left side. Let's try to write down on the right side based on theta 2. So if we want to write the equation based on theta 2, we can write in this way. At first we can convert T1 into T2 by multiplying N2 by N1. You can see here T1 into N2 by N1, which is actually T2, and then we will have to transfer this inertia to the right side, and it will become like this one. J equivalent is J1 into N2 by N1 whole square plus J2. Okay, so equivalent inertia J will be summation of this J2 plus the transferred version of the J1, which is equal to J1 into N2 by N1 whole square. Here we can see that we are multiplying N2 by N1 because we are going from N1 to N2, so N2 will appear on the top. Okay, so this is the inertia we are getting equivalent inertia on the right side. So you cannot just use J2, you have to include J1 as well. Whatever on the whatever impedance lying on the left side, you have to include it on the right side, but you have to transfer it. So this is the equivalent inertia Je. Similarly, we have a d1 here. We have to transfer it and add it to the d2 to write the equation on the right side. So the equivalent inertia will be d1 into n2 by n1 whole square plus d2, and there is no spring here, so nothing to transfer here. The equivalent spring will be just k2. That's it. So now we can write down the equations. So this is the equivalent Je, equivalent inertia. This is the equivalent viscous damper, and this is the equivalent spring constant. And finally, we can write down the equation like this: Je square plus Des plus Ke into theta 2. So all of this impedance, all three impedance are connected to theta 2, and then we are setting equal to T2, which is equal to T1 into N2 by N1. Now we can easily find the transfer function theta 2 by T1. Okay, theta 2 is our output and T1 is our input, which is equal to this one. Okay, so this is how we find the transfer function for a system with a gear. Now, what will happen if we want to find transfer function in other ways, something like theta 2 by T1? We have already found it, but if we want to find theta 1 by T1 or theta 1 by T2 or theta 2 by T2, etc. So let's see if you can. So this is the transfer function we already found, and let's see if you can do it. Please try to now pause the video here and try to write the equation based on theta 1 using this diagram. Okay, so in this diagram there will be another equivalent J, there will be another equivalent D, and another equivalent K. To find this equivalent J, D, and K, you have to transfer this J2 to the left side by multiplying n1 by n2 whole square, and similarly by transferring D2 and K2 to the left side. Can you write the equation? Please pause and try. Can you find the transfer function theta 1 by T1? If you finished writing this equation and transfer function, you can also try to find theta 2 by T2 and theta 1 by T2. So in this case, what you need to do is to change the theta 2, or you have to change T1 into T2 by using the ratio. We know theta 2 by theta 1 is equal to n1 by n2, or T2 by T1 is equal to n2 by n1. So using those previous formula, you can change the variable theta 2 to theta 1 or T1 to T2, etc. Please try to solve this on your own. Next, we are going to discuss about gear train when we have a number of gear are added one after another. So here we can see the first gear combination is n1 by n2, the second gear combination is n3 by n4, and third gear combination is n5 by n6. And we can write the equations between this theta with this theta 1 like this: theta 2 is equal to n1 by n2 into theta 1, and theta 3 is equal to n3 by n4 into theta 2, which can be rewritten as this. Okay, because we know the theta 2 from here, and we replace this formula here and we get this one, right? And finally we can see that theta 4 is nothing but theta 1, which is this one, multiplied with all this ratio n1 by n2, n3 by n4, n5 by n6. You can see that here. So it's very simple. We just multiply 3 times here, that is 3 different ratio, n1 by n2, n3 by n4, n5 by n6. instead of 1 we are multiplying 3 terms here. So we have to remember this formula, that we have to multiply multiple times the gear ratio to find the theta 4 from theta 1. Now let's consider a system where we have two gear setup here, but we have some inertia. We can see that there is inertia connected to the to this side, and also there are some weight of the gear here. We know I think you when the gears are very the weight of the gear is not negligible, we have to consider some weight of the gear, which is inertia J4 here. And similarly we have some weight of this gear J2, J3. This gear, this circular gear can be heavy, so we are including some inertia here G2 and G3, and here J1. Sometimes we can ignore this inertia if these gears are very light, but sometimes we cannot. So if we cannot ignore the weight, if weight is heavy, so in that case we have to include this inertia. Okay, and also we are including some friction here, viscous damper D1, which is associated with this axis D1. So we are assuming that we have some friction which is not negligible, so this inertia is included D1 as D1. Similarly, there are some inertia in this axis which is D2, which is included here. So D2 is associated with this axis or this angular displacement, whatever it is, for example theta 2, and this is theta 3, something like that. So and the viscous damper or friction associated with this axis is negligible, so we did not write it down here. So now let's try to write the equation on the left side of the gear that is based on theta 1. So we are going to write the equation right here. So if we want to write the equation here, we need to find the equivalent inertia, equivalent viscous damper on this part of the system. So we have to transfer all these J and J2 and J3, all this inertia we need to transfer to the to this theta 1 area. So let's do that. So how can we do it? You can see that the final equation, if we can transfer the inertia and damper to the theta 1, we can rewrite the equation. We can write the overall equation like this, that is theta 1 into J1s square plus DES equal to T1. So that will be the simplified equation. But before that, we need to find what is the value of JE. So JE is this one. So let me explain. So JE is the equivalent inertia on this area, in this part, and we can see that there is a J1 which is directly connected to the theta 1. So we do not need to transfer this J1 because J1 is already associated with theta 1. Next, we can see that J2 and J3, they are both in the same axis or the same displacement theta 2. Let's say the displacement is theta 2. So J2 and J3 are both associated with a theta here, theta 2. So we need to transfer these two together from this area to this area, and the transfer formula is n1 by n2 whole square. So this is it. So we are transferring it. So often we see that the student make mistake that J2 is transferring by N1 by N2 but they are not transferring the same J3 using the same formula, because they think that J3 is associated with N3. So this is a mistake. We have to remember that J2 and J3 are on the same axis and the same theta 2, and to transfer from theta 2 to theta 1 we have to multiply with N1 by N2. So we cannot use N3 for J3, rather we have to use N1 by N2 whole square for both J2 and J3 because they are in same axis. Similarly, for J4 and J5 they are in same axis, for example theta 3, and we have to transfer it from at first from here to here. How? N3 by N4 whole square by multiplying this factor, and then we have to transfer from here to there, that is N1 by N2 whole square, which is the principle of gear train. We have to multiply 2 times, N1 by N2 and N3 by N4 whole square. So we have to first transfer from here to here and then here to here. So as a result we have 2 factor here. Okay, so this is how we will transfer J4 and J5 to the area of theta 1, and then we can write equivalent inertia JE, which is summation of all these 3 components. Similarly, you can transfer G2 from here to here by multiplying N1 by N2 whole square, and there is no other D here, so that's all. I hope you understand this principle now, how to transfer impedance from one side of the gear to the other side. And once we are done, we can write the transfer function from this equation, that is theta 1 by T1 is equal to 1 by this factor. Okay, so we have to write down all the values of GE and DE. So let's say let's now solve another. Let us now solve another system with 2 variables, but here we are also facing a gear. In this system we have 2 variables. How? 2 independent variables. Okay, we can see a gear here. There is a variable theta 2. There is a variable theta 2 here, theta 2, and we are writing the variable on the left side of the gear theta 2 dash. So basically these theta 2 dash and theta 2, they are not independent variables, they are dependent variables. So we are, instead of writing theta 3, we are writing theta 2 dash to indicate that they are basically same variable. And we have a viscous damper here, so both sides of the damper should contain different variables. This is the fundamental rule we have to remember. So we have another variable theta 1 here. So this is theta 1, this is theta 2, and this is theta 2 dash. These 2 are dependent, so number of total independent variables are 2, not 3. Okay, so we have an input torque here. So now we are going to write how many equations? How many variables are here? Theta 1, theta 2 dash, and theta 2. So are we going to write 3 equations? No. We already have repeatedly mentioned that theta 2 dash and theta 2 are dependent variables. So we will consider only one independent variable both on the left and right side of the gear. Okay, we will write the equation either here or here, not on both sides. Okay, and we will write another equation based on theta 1. So let's try to write down the equations. So the first equation will look like this one, that theta 1 multiplied by the impedance, that is 1 into s square, and 1 into s, there is no spring here, and then minus the variable theta 2 dash. But before, instead of writing theta 2 dash, we will try to write down in terms of theta 2, because the question is in our question it is written that we have to find the transfer function theta 2 by theta t. So we will try to write down in terms of theta 2. So for that we need to convert this theta 2 dash in terms of theta 2, that is by using our basic formula, theta 2 dash by theta 2 is equal to n2 by n1. So these are the formula from our previous slide, and then we can write down theta 2 dash is equal to 2 theta 2, because n2 by n1 we can see the value 50 by 25 is equal to 2. So instead of writing theta 2 dash here, we can write simply 2 theta 2. Okay, so we are writing 2 theta 2 into s, just like the mesh equation. So we have practiced it in our previous lecture. So theta 1 into some impedance and theta 2 into the sharing impedance, which is 1 into s here, is equal to the applied torque T1 T. And then we will write the second equation based on this theta 2 dash here. So the same as will appear with theta 1 minus theta 1 into the common impedance here, s 1 into s, and then minus this should be plus the plus 2 theta 2 into s plus 4 into 25 by 50. How it comes here? Because we need to transfer this spring from the right side of the gear to the left side of the gear. So we need to multiply it with 25 by 50 whole square, right? So in this way we should transfer the spring to the left side, and then should be included as an impedance with 2 theta 2 or theta 2 dash. So the total impedance is the s plus 4 into half a square. Okay, so we put them together with 2 theta 2 is equal to 0. I hope you understand these equations. Try to pause the slide and try to write on your own. Okay, the more you practice, the more you will understand. So if you can write these two equations, you can easily solve these equations by Cramer's rule. Before that, you have to rewrite the equations in a matrix format, and then you can solve theta 2 by delta 2 by delta, and finally we can get this transfer function. Please try to solve by yourself and see if this answer matches with yours.